we go, guys. Now, yesterday, I need your attention, please. We did volume of a cylinder, all right? And I asked you a question, is a cylinder a prism? Yes. So does the formula change for area of a prism? No. What is the formula for area of a prism? Area of the base times the height. That is exactly correct. Area of the base times the height. Can the base change? Yes, the base can change shapes. It can be a circle. It can be a triangle. It can be a rectangle. It can be a square. It can be a trapezoid. It can be a pentagon. It can be anything. But the point is you have to find the area of the base. And then you just multiply it by the height. So now, today, that kind of reminds me of a what? Pyramid. All right? And a pyramid can be the same as a cone. All right? The cone just has what type of base? A circle. That is exactly correct. So, can pyramids, like prisms, have different bases? Yes. Now, if I ask you a question here, are there two bases?
No.
No, there aren't two bases. Now, what I want to do is, I want you to please look up here on the board for a second. All right, I want to try to show you something. All right. Now, I'm going to draw this, and I'm going to try to make it look like a prism, just to show you something. How when you forget, you can figure things out. All right, so I'm going to try to draw this as a prism. So please try to watch. That was a little too thick, so I'm going to do this. I'm going to do this. All right, now watch what I'm going to do. Just watch now. I'm not. You don't know what the question is, so you can't tell me you don't understand. All right. Now, what I'm going to do now is I'm going to do this. Now, what did I just create?
A square.
No. I created a triangular prism. I created a triangular prism. So what is the formula for the triangular prism? Volume equals still what? Base times height. All right, hold up a second, because I'm now trying to teach you how they figured out the volume of a pyramid. So is the volume of a pyramid going to be more or less than the volume of the prism?
Less.
It's going to be less. Now the question I have for you is, how much less is it going to be? How much less is it going to be, Chloe Clay? Half. I think that is a very good guess. That's a very good guess. What are you thinking? I'm not saying that's correct. I'm saying that's a great guess.
A quarter.
A quarter. I think that's brilliant.
A fourth. I'm an eighth. Sorry.
An eighth. Good.
3 times less.
3 times less. 3 times less. What do you think?
It's going to be the pyramid times 2.
Pyramid times 2. That's not bad. What are you thinking? Yep.
1/2.
So he thinks 1/2. Now watch what I'm trying to show you.
Base times height.
All right. So we're going to see what if your theory holds up. Now watch. What I did here was I cut. All right. So I'm going to remove it. So I'm going to come over here and I'm going to remove, well, that wasn't very good. Let me go back, because of the way I shaded it in. All right, I'm gonna reshade it in though. So I'm gonna shade a little bit at a time. This might be giving you too much of a hint. But this is how I remembered it. So what fraction is it? What fraction is it? Somebody else? What fraction?
1/3.
Yeah, 1/3. All right, now it's kind of silly to me. All right, please look up. All right, but that's kind of how I envisioned it. I just cut this piece right here. Please try to see. I cut that piece. Right, that sliced 1/3 of it. And then I did what? I sliced this piece, and that's another what? 1/3 of it. All right, so I broke it down into what? Into 3 parts. This volume of a pyramid is exactly 1/3 of the prism. So you hear what I just said? So the volume of a pyramid, instead of being base times height, you're going to tell me is what? 1/3 base times height. Yes, ma'am. I know, but because I removed 2 parts, there's how many parts left? There's 1 part left. All right, I'm a little better at drawing this. Watch. I'm going to draw a cone for you. I can do it better this way, I think. All right, let me see if I can show you a little better. All right, so now I'm going to put this down here. All right, now what I'm going to do is I'm going to draw this piece from here to here. I'm going to draw this piece from here to here. This, all of this volume in here that I removed from the cylinder represents what part? 1/3. This part over here represents what? 1/3. Combined it represents 2/3. So I sliced it this way and I sliced it this way, and so how many thirds remained? 1/3. Now again, I don't care how you remember it. I'm just telling you how when I was learning these formulas, it was annoying because it seemed like there were so many formulas. Are there really so many formulas? No, there isn't. All the formulas are the same except for the no, except for the base. Except for the base. The formula is the same. The base is what changes. Come on now, I'm trying to make you super smart here. I don't want you memorizing every single formula for every single prism, for every single cone, for every single pyramid. There's all different types of formulas. All you have to know basically is, can you tell me the area of a circle? Do you know the area of a circle?
Yes, I do.
Yes. Do you know the area of a triangle?
Yes.
Do you know the area of a square?
Yes.
Do you know the area of a rectangle?
Yes.
Do you know the area of a trapezoid?
Yes.
Then you know all the formulas for what? Volume. Because all the volume has everything to do with the what? Area of the base. If you know the area of the base, you can calculate the volume. If I ask you for a prism, you're going to tell me the volume of a prism is just the area of the base times the height. If I ask you for the volume of a pyramid, you're going to tell me it's the area of the base times the height times 1/3. That's how simple it is. So if you understood yesterday and the day before when we had prisms, now you understand what? Pyramids and cones, because it's the same thing, just with the fraction what? 1/3. Listen, I cannot tell you how simple that is. All right, it's super easy, but most kids make it too hard because they try to memorize a formula for every single shape. I don't want you doing that. I want you to say the volume of a prism, base times height, volume of a pyramid, 1/2, or volume of a pyramid is 1/3 base times height. And then you just have to tell me what the shape of the base is. Then you know the formula. All right, so let's see if you understand now what I'm talking about when I'm asking about question number 1. All right, so I want everybody to write down V equals 1/3 base times height. Then underneath there you write V equals 1/3. Somebody tell me what the base of this shape of this pyramid is. That would be a
what?
What's the base?
It's a triangle. Sorry.
Triangle. So what's the formula for area of a triangle?
1/3 BH.
1/2
BH.
1/2 BH. Don't be sorry. Good. So now please watch. So now after you put down 1/3, you have to put down times what? 1/2 little b little h, then what?
I'm sorry.
Big height, capital H. That's what we're doing. All right, to me that's simple. So here we go. Let's see how smart we are. So V equals 1/3 times 1/2. What's little b? What's little h? What's big H? Wow, that's really nice. If you know that, that's super, super, super important. And super what? Easy. Super easy. All right, now take out your handy dandy calculator.
408.
And tell me, wow, 408 what? No.
Pyramided.
Pyramided.
Yay,
What is a pyramided? All right. Yes, the pyramid. You can put 408 cubic inches in that pyramid. That is true. 408 cubic inches in that pyramid. Yes, ma'am.
This is kind of a weird question. But in a cone, it's like round. So like the cubes would have to be rounded.
You're almost correct. All right. Now, listen, that's a pretty good understanding, right? But it's just like in a circle. Watch. All right. You don't measure in a circle the area in circles. What they end up doing, this was a hard thing for them to figure out. If you're understanding, if you were to find area, eventually all of the squares here, but then some of them up here, you are just approximating what that square is. You hear me? So it's not circular at all. All right, you always measure in squares. All right, so here we go. Now, number 2. Tell me, the formula for a cone is what?
1/3 base times.
Yes, that's exactly what I want you to say. 1/3, say it again.
Big B.
Big B and big H. All right, so now you have to tell me the base area. Go ahead. Shh. I'm not interested in you running your mouth. I'm trying to teach. Keep it quiet. Go.
1/3
Good.
times pi R2 big H.
Now you look like a genius. All right, you can tell me every single formula for anything if you know the basic shapes for the base. It's super, super easy. All right, now continue on. Tell me what the radius is. Shh, I'm listening to Lucas.
1.5.
Good. And what's the height?
3.
You're awesome. All right. So, type it on your calculator, please, and give me an approximation for this. Shh, hold on. I'm waiting for Lucas. I'm waiting for Lucas. 7 point what?
07.
About 7.07 what?
Yards square. Cube.
Yes. Anybody else get around 7.07?
Yeah.
James, what?
What's 1/3 in decimal?
0.3 repeating. Right? You knew that.
Because
All right. Shh. Yes. I thought you tried number 1. So let's let someone else try number 3. Go.
so
Volume equals what? Good. Good. Beautiful. Go. And that would be
meters cubed.
meters cubed.
Oh, so
Or you could just change to 1/3, or you just put 0.3. What?
can I check the next one?
What?
On number 1, I think I'm 12, and 12 would be the center of the base.
Because it's the right angle here. You okay with that now?
Yeah. Yeah, I see.
Okay. It's kind of hard the way they have that, you know what I mean, drawn. Alright, what?
Is there a way for like cubic things to go into square things?
No, because a cube is 3-dimensional, a square is what? 2-dimensional.
So like, what if something gets moved on the shape?
Then it's no longer a cube.
So would it be like the same thing square, or would it just be?
You measure area with squares. You measure volume with cubes. That's it. If I want to know the area of the wall, I wouldn't say that's 10 cubic feet. If I wanted to see the area of the floor, I wouldn't say that's 12 inches. Area is measuring in squares. Volume is measuring in cubes. You with me? All right. Number 4. All right, Elise, go.
We don't have 4 or 5.
We have
Oh.
6 questions. We have 7, 8, 9.
Really?
Yep.
All right, so let's look up here. All right, just put it on the back somewhere or do something. I don't know what happened to my copies. All right, so here we go. This is just a what again? It's called a cone. All right. So Elise, tell me what to do.
So it is 1/3 of the
Good.
of pi squared,
Good job, girl.
and then it's 1/3 pi 6 squared times.
You're amazing. Go. Tell me what the answer is.
Um, 376.7.
And then,
Wait.
I don't care. Tell me what. Units.
Oh, right. Meters cubed.
Good. Is everybody else okay with that? Everybody okay? Everybody good?
No, can you read it? I wrote 376.
Seriously, come on.
Is there
Shh. No, I mean, if you got 376 and she got 376, am I going to argue over the decimal place?
No.
No, what are you asking me? All right, number 5 is a new shape for us. Now, again, there's nothing I can do for you on here. So, hear me? Nothing I can do. It's just a formula. All right, you do have to memorize this formula. All right, so I need everybody to look up volume. And if you want, does anybody know what that's called?
sphere?
Sphere. That's correct. Sphere. All right, and that volume is 4/3 pi r cubed. 4/3 pi r cubed. That is the formula for volume of a sphere. 4/3 pi r cubed. You just have to memorize that. All right, I don't really like to tell you to memorize a whole bunch of stuff, but that's something you have to memorize. 4/3 pi r cubed. Okay, so what's the radius here, guys?
1.5.
Yep, so it's just 4/3 pi 4.5 to the third power. And remember, to the third power is the caret button with the 3. The caret button with the 3. Now, some of you have y to the x button. You might use that. But most of the time, there's a caret button now.
Wait, so it's that?
Good job. And then 3. So, Aiden, what did you get?
381.7.
And then,
7 meters cubed.
yeah, I'm okay with that. I'm not saying he's correct. That's why I need some help.
I got the same thing.
Same thing? All right, so I'm making sure you understand how to use the cube button on your calculator.
To the radius 2.
This isn't cubed.
I'm on number 6 now. Yeah, 4/3 pi r cubed, not squared. You have to do y, so hit no, this button. And then 3. All right. So just for practice now, number 6. Sorry about the worksheet again, guys, but just write it down. Make sure you write it down.
Oh.
All right. Oh, what?
I never recorded that, but I didn't know.
Well, that's what we're doing. Come on, you're brilliant.
Could you please scroll up for just a second? I just need to see the. Okay, thank you.
All right, so again, for number 6, volume equals. And again, the reason why I want you to write it is because it helps you memorize. All right.
Can you show me where that
The,
Okay, there's the one next to that. It's a BPS.
Can you scroll things up for me real quick?
what?
Can you please hold from the 4.5 seconds?
Why I'm on number 4?
I just need 2 seconds. I just need 2 seconds. Well, like 5. I got something different.
For which one?
For number 5.
So type in 4 divided by 3, or 4/3, however you
That's
want.
why. I did 3/4 instead of 4/3.
Okay, so double check that. All right, so for number 6, again, volume equals 4/3 pi times what?
R cubed.
Right, and r in this case is, all right. You agree it's 7?
Why is it 7? I thought that would be like height.
The diameter would be, if they're giving you the diameter, they would have drawn the whole thing in.
Oh, so it's just.
Yeah, that's why you know it's a radius. All right, so now please be careful. That's why I'm asking you to use your calculators. Learn how to type things in on your calculator properly. All right, did you get the volume? What is it?
Oh,
Volume is, shh, I'm waiting.
that is not what this is.
Well, just tell me. I'll be the judge.
It was like a fraction inside of it.
All right, so someone tell me, what did you get?
1,436.777. Feet.
There we go. Is everybody happy with that? All right, everybody happy? All right, here we go. Let's have some more fun. Number 7. Do you guys have 7, 8, 9, right?
Yeah, so that's
Yeah, I don't know what happened. All right, here we go. 7. Find the volume of a rectangular pyramid with a length of 14, a width of 12, and a height of 9. So a rectangular prism, still, formula is V equals what? Tell me, Michaela.
1/3 base times height.
Right? So,
And then it's 1/3 like times width times height.
yep.
And then it's 1/3 14 times width times height.
Perfect.
Wait, why is it there a half?
Because it's not a triangle.
Oh, is it a pyramid?
Pyramid is 1/3.
And then the answer is 504 feet cubed.
504 cubic feet. Everybody happy with that? It's not bad, right? What? All right, now here we have the Eiffel Tower in Paris is not a solid pyramid. Its shape approximates that of a pyramid with a square base measuring 120 feet on the side and a height of 980 feet. So if you had to fill this up, does everybody agree with me? If you had to fill it up with concrete or something. All right, we want to know how many cubic feet you would need. All right, so what's the formula?
1/3. Well, B equals 1/3 B times big B times big H.
So now, what's the base?
Times S squared
Yes, good job.
times big H.
What's the side of the Eiffel Tower?
120
Good.
times 980.
Look how big that is. How many cubic feet you would need?
A lot.
A lot. Go.
Exactly 400. You know, 4,740,000.
Shh. Like this?
Yes.
All right, that's a lot. Can you imagine having to fill that thing up?
4,000.
4,704,000 cubic feet to fill the Eiffel Tower. Yes.
Well, is this like the final formula for these two together?
Yeah, because it's a square base.
Okay.
All right, now why do you think I highlighted 18 inches? Because why? No.
Oh,
Why?
because the rest of the diameters are feet.
Yes. All right. The other ones are feet. All right. So you always have to measure with the same units, correct? So I need someone to tell me what 18 inches is in terms of feet. Do you know, Chloe? 6.5. Think about it. Shh. Don't tell her. Yes, 1.5. I know, I didn't hear you either, so don't worry. All right, so 18 inches, I need everybody to write down, 18 inches is equal to 1.5 feet. That was the trick to that question. All right, does everybody understand we're drawing a snowman that's just 3 spheres, correct? Now, it's the diameters though, correct? So volume 1 equals, what's the formula for a sphere again?
Oh,
What?
4/3 times pi plus r cubed.
Yes, 4/3 pi r cubed. Exactly. All right, so here's snowman's, the first one, the first sphere is 4 feet what? Diameter, so that means its radius is what? 2. So it's going to be 4/3 pi times 2 cubed. Volume 2 is going to be 4/3 pi. What's the radius? 1 cubed. And then volume 3 is going to be 4/3 pi. What's the radius? 0.75 cubed. Then what do I do with all 3 of those? You add them together. So when you think you have the answer, let me know. Tell me.
51.84.
Anybody else get 51.84, and then it would be what?
Inches.
Is it inches or feet?
Feet.
Cubic feet. Anybody else get 51.84? I'm not saying she's right.
So like not exactly.
No, I know, approximately. Good? Well, what did you get?
39.85. I probably did it wrong.
39 point what?
47. Yeah.
About 47 cubic feet.
Yeah,
So
that's what I-
just double check. All right, it's not a big deal. All right. Yeah. Anybody have any issues? Don't you agree that's pretty easy, right?
I have a question.
I'm
How
listening.
did you get 0.75 for radius?
Half of 1.5,
Darn it.
right?
Right. Okay.
Do you guys have 10 and 11?
No.
Really? You don't?
No.
All right. How much time do we have?
10 minutes.
All right. So this is beautiful. We got to end the day on a good note here, guys. No homework.
We're doing 10.
All right. Yeah. So just find a spot for 10 and 11. All right. The Great Pyramid of Khufu in Egypt has a square base measuring 750. What?
You know about it.
Measuring 756 feet on a side and a height of 481 feet. The stones used to build the Great Pyramid were limestone blocks with an average volume of 40 cubic feet. So how many blocks were needed? All right. So I first have to figure out what the volume of the pyramid is. What's the formula for volume of a pyramid? Again, yes.
1/3. When you do it with the square
Yes, so that's going to be
size square size times capital E.
you are awesome. Beautiful. So what's the side?
756.
Times what's the height? 481. Guys, that is amazing. All right, so tell me what the volume is in cubic feet. I'm waiting. So, yeah, 636,000. Come on. And then what? Shh. What are the last three numbers? So there were that many cubic feet. However, each stone was 40 cubic feet. So how do I figure out how many stones were needed? How many stones were needed, Harrison? What do I do? You divide it by 40. That is correct. 2 million what?
2,290,907. God, I feel bad for those aliens.
All right, so it's gonna take you 2,290,907 stones. All right, to build that pyramid. Yes. All right. Last one. A giant soccer ball has a diameter of 40 inches. Find the volume of the soccer ball. So, soccer ball is a sphere. So what's the formula? Yes. 4/3 pi r cubed. All right, so the diameter is 40, so the radius is 20. So here we go. Volume equals 4/3 pi times 20 cubed. So what is the volume? Come on. 335 what?
0.32.
Okay. Is that right now? What, is that what you said?
33,000.
Okay. So 33,510 cubic inches. Okay. Now it says also, shh. How long will it take the ball to deflate if it can deflate at 100 cubic inches per hour? So what would I do? Shh.
You would divide that by 100.
Divide that by 100. And it would take you how many hours?
Take 335.1
How did I know that? Divided by 100, what do you do to the decimal? Move it over 2 places to the left. Is everybody with me on that? Everybody good? All right. So again, that was the final lesson on volume. So you know everything there is to know now about different types of volumes of different types of shapes. Don't worry, listen to me. Tomorrow, listen, we're going to do the IXL on volumes. All right? You have to be able to type in the volume. Right? No, you don't need your binder tomorrow. However, listen, then on, that makes Thursday, we have review for volume on Thursday and Friday, and then our test will be on Monday. You're welcome. I think it'll be a quiz, yes. All right, run up and get me some other ones real quick.